became interested in science in 6th grade because of one of my science teachers. She made everything really hands-on, and she had us do a bunch of experiments and reactions that I really enjoyed. I'm a very hands-on learner, so it was a really great experience for me. I particularly became interested in chemistry because I felt that everything revolved around chemistry. Everyday life is because of it. I had a lot of trouble studying when I first came to college because I was not how to study correctly for my learning type when I was in high school. I later learned that I learned best by writing stuff over and over, so I make out flashcards and write my notes over. Some people study really well in groups, and other people study just by themselves. And some people just like to have people study quietly around them, so it all just depends on your preference. But try out different study styles and see what works best for you. So coming into college, all the seniors tell you, like, time goes by so fast, just make sure you enjoy it, make sure that you get all the experience you can. And I know you hear it from everyone, but like I, as a freshman, was like, yeah, sure, whatever. And then as a senior, I'm like, oh my God, where's time to go? It's like, really just make sure you take every opportunity that you can and go out and do the things you want to do, because time does fly really, really fast. And I am so happy that I started new experiences and did things that I wouldn't have otherwise done. So today we're going to be talking about percent yield. Percent yield is the percent ratio of actual yield to the theoretical yield. And it's calculated to be the experimental yield divided by the theoretical yield multiplied by 100%. Percent yield is always going to be a positive value. So the experimental yield is what you get during your experiment. It most likely is not always 100%. It's usually under 100% due to incomplete reactions or a loss of the sample during the reaction, but every now and then it can be over 100%, which means there was byproduct or impurities in your reaction. So to calculate percent yield, you take the experimental yield and divide it by the theoretical yield, and then you multiply it by 100. All right, so we're going to start off by working out an experiment. So in this experiment, we formed 15 grams of magnesium oxide, and the theoretical yield of magnesium oxide is 14 grams.
It's 19.
Okay.
You can just start with that. That's a really pretty color. Sorry, I would have let you go except for the numbers.
Yeah, you're right.
And you paused too, so it's not a big deal. At least it was like me, and I literally wrote an entire book about it and messed up. Put it in the wrong books. Okay, so with the 19.
I'm just going to start over. Okay. So for our first example, we're going to work through this problem. So magnesium carbonate goes to magnesium oxide and carbon dioxide. So in our experiment, we found that we formed 15 grams of magnesium oxide, and the theoretical yield was 19 grams magnesium oxide. So to find the percent yield, it's the actual divided by the theoretical times 100. So we start with 15 grams of magnesium oxide is the actual divided by 19 grams. It's the theoretical, and then we multiply it times 100, which gives us 79%. All right, for our second example, we're going to go through a theoretical yield problem and then move into percent yield. So for our theoretical yield problem, we start with 40 grams of potassium chlorate, and we're going to transition that to dioxide. So first, we want to transition grams into moles. So the molar mass of potassium chlorate is 122.55 grams potassium chlorate in 1 mole. And we want to transition that to moles of dioxide. So for every 2 moles of potassium chlorate, there is 3 moles of dioxide. And finally, we want to transition the moles of dioxide back into grams. And so the molar mass of dioxide is 32 grams for every 1 mole. And then you plug that into your calculator and you get out 15.7 grams of dioxide. And so now we're going to calculate the percent yield. So the experiment's performed and the actual mass of dioxide was collected, and it was found to be 14.9 grams. And so we take the experimental yield, and we're going to divide it by the theoretical yield. It's 15.7. And then we're going to multiply that whole thing by 100. And that'll give you 94.9%. And that is your percent yield.